For one full morning, the sun went completely silent. Not quiet, not slow, silent. On February 22nd, scientists confirmed something they hadn't witnessed in nearly 4 years. The sun's entire Earth-facing surface had gone completely blank. Not a single sunspot, not one active region. Just a smooth, burning disk of light with nothing unusual visible anywhere on it. The last time that happened was back in June of 2022. In the years between, the sun had been in almost constant motion, flaring, erupting, launching storms toward Earth one after another. 4 years of non-stop solar activity. And then, just like that, it stopped. For a brief moment, solar scientists around the world allowed themselves a rare pause, but that moment didn't last long. Because less than a day after that historic blank sun, while astronomers were still documenting it, still writing about what they had just witnessed, the first edge of AR4366 appeared exactly where scientists expected it, right on schedule. Something that had been travelling around the hidden backside of the sun for nearly 2 weeks. The most dangerous sunspot of the year was coming back. In the next several minutes, we're going to walk through exactly what this sunspot is, what it did the first time it faced Earth, what happened while it was hidden on the far side of the sun, what scientists found when it came back into view, and what the next several days could look like. We're going to talk about what it means for GPS systems, power grids, radio communications, the things you actually use every single day. And we're going to discuss why this particular moment matters more than most people realise. This is the next chapter, and it's happening right now. If you've been following along with our channel, you already know the name of this sunspot. You already know what it did during its first pass. But if you're joining us for the first time, welcome. Because what's happening this week is scientifically significant, and you're about to understand why. The sunspot is called AR4366. And when it first appeared back in late January, nobody knew it would become what it did. It looked like a lot of other sunspots at first. Just another dark patch rotating into view on the sun's surface. Something to monitor. Something to keep an eye on. Scientists marked it in their catalogues and went about their work. But within days, this region had grown into something that made solar scientists stop what they were doing and stare. It became so wide it could have swallowed Earth many times over with room to spare. Astrophotographers around the world, people with backyard solar telescopes, started posting images of it and couldn't believe what they were seeing. From the very first days of February, AR4366 began firing. First a few large eruptions, then more. Then, in what scientists would later describe as one of the most intense periods of solar activity recorded in years, this single sunspot produced flare after flare, more than 24 significant events in a single day. The strongest of those eruptions ranked among the most powerful flares recorded in the entire current solar cycle. NOAA, the agency that monitors space weather for the United States government, put out official alert after official alert. What made this sunspot especially dangerous wasn't just how much it was firing. It was the type of magnetic structure it carried. Solar scientists classify sunspot magnetism on a scale, and the most dangerous level, the one that makes eruptions both powerful and unpredictable, is something called a beta-gamma-delta configuration. It's the solar equivalent of a coiled spring with the tension wound as tight as it can go. AR4366 had that classification, maintained it, and kept firing. By the time it began rotating away from Earth's direct view in early February, it had fired well over 50 significant flares. It had disrupted radio communications across wide parts of Earth's sunlit hemisphere. It had launched massive clouds of solar material in multiple directions, some of them brushing past Earth, some passing to the side. The question that every solar scientist was quietly asking was simple. Would it still be there when it came back around? And if it was, would it still be dangerous? Before we go any further, if you find yourself watching videos like this trying to understand what's happening with our sun and what it means for all of us, hit that subscribe button right now and ring the notification bell. Every time something significant happens up there, we cover it clearly, accurately, and without sensationalism. Drop a comment below. I want to know, where in the world are you watching from, and have you ever seen the Northern Lights? Let me know. Those 2 weeks it was hidden, and what scientists found when it came back, is where this story gets genuinely interesting. Let's go back to late January 2026. The sun had been fairly active that month. Some flares here and there, nothing too alarming. Scientists were tracking the normal rhythm of solar cycle 25, the 11-year pattern our sun follows as it moves from quiet to active and back again. And then, out of almost nowhere, a new sunspot region appeared on the eastern edge of the Sun. It was called AR4366. In the beginning, it looked ordinary, a dark patch on the Sun's surface, something to keep an eye on. Scientists marked it, monitored it, and continued with their day. But AR4366 grew into something far more active than expected. Within days, not weeks, not months, just days, this sunspot had grown into something that made solar scientists stop what they were doing and look twice. It became enormous, wide enough to swallow Earth many times over. Astrophotographers around the world, people with backyard solar telescopes pointed at the Sun, started posting images online. The reactions were immediate. What is that? How did it grow so fast? One astronomer in Argentina photographed it and described what she was capturing as a solar flare factory. That phrase spread quickly through the solar science community, because it was accurate. AR4366 wasn't just large, it was restless, active. It carried a magnetic structure that made eruptions not just possible, but likely. From the very first days of February, AR4366 began firing. First a few large eruptions, then more. Then, in what scientists would later describe as one of the most intense 24-hour periods of solar activity recorded in years, this single sunspot produced eruption after eruption after eruption. More than 24 significant events in a single day. To put that in perspective, most sunspots produce a handful of flares during their entire Earth-facing pass. Some produce none at all. AR4366 was firing multiple times per day, and some of those eruptions were massive. The strongest of those events ranked among the most powerful flares recorded in the entire current solar cycle, which began back in 2019. NOAA, the agency that monitors space weather for the United States government, issued alert after alert. Solar scientists around the world watched their monitoring screens and quietly acknowledged what they were seeing. This was not typical behavior. What made AR4366 especially dangerous wasn't just the volume of eruptions, it was the magnetic structure underneath. Solar scientists classify sunspot magnetism on a scale. The simplest sunspots have what's called a beta configuration, relatively stable, low risk. More complex regions have beta-gamma structures, higher energy, higher risk. The most dangerous classification, the one that makes eruptions both powerful and unpredictable, is called beta-gamma delta. Think of it like this. A beta sunspot is a calm lake. A beta-gamma sunspot is a river with a strong current. A beta-gamma delta sunspot is a dam holding back enormous pressure, one that can release that energy suddenly, without much warning. AR4366 carried a beta-gamma delta configuration. It maintained that classification for days, and it kept firing. By the time it began rotating away from Earth's direct view in early February, it had fired well over 50 significant flares, including multiple events in the highest energy category that exists. It had disrupted radio communications across wide parts of Earth's sunlit hemisphere. Commercial aviation had to reroute some communications. Emergency services experienced brief blackouts in certain frequencies. GPS systems became slightly less accurate during peak storm periods, and it had launched massive clouds of solar material in multiple directions. Some of those clouds brushed past Earth, some passed to the side, some missed entirely. But the fact that this sunspot was capable of launching that much material, that frequently, made it one of the most closely watched regions in recent memory. And then, around February 8th, it rotated over the western edge of the Sun and disappeared from Earth's view entirely. Gone. Out of sight. Hidden on the far side of our star where no direct Earth-based telescope can follow. The question that every solar scientist was quietly asking was simple. Would it still be there when it came back around? And if it was, would it still be dangerous? Because here's what scientists know from experience. Sunspots don't all behave the same way on the far side. Some regions, once they're out of view, begin to fall apart. The magnetic energy that powered them gradually unwinds. The dark spots fade. By the time the Sun rotates them back into view, what was once a massive, dangerous region has become a quiet, harmless smudge, or disappeared entirely. But other sunspots, they don't weaken, they stabilize, some even reorganize during the far side transit, and come back into view carrying just as much energy as when they left, sometimes more. So when AR4366 disappeared in early February, scientists had to do something that doesn't come naturally to people who study space for a living. They had to wait and watch the indirect signals. and wonder. Because the sun doesn't send us a notification when something significant is happening on the far side. We have to wait for it to come back around, and that wait, for a sunspot this powerful, felt long. Here's something most people don't think about. The sun is a sphere, a giant, turning sphere, and like Earth, it has a side that faces us and a side that doesn't. At any given moment, roughly half of the sun's surface is completely hidden from Earth. We can't see it directly. Our telescopes, our satellites, our ground-based observatories, none of them can look around to the backside of the sun and show us what's there. Scientists have some indirect tools. They can read ripples in the sun's surface, almost like sound waves travelling through the interior, and use those ripples to get rough outlines of what large features might be lurking on the far side. It's a bit like pressing your hand against one side of a drum and feeling the vibrations to guess what's hitting the other side. It gives clues, but not certainty. So when AR4366 rotated out of view around February 8th, scientists had to rely on those indirect signals. And they had to wait. The sun rotates slowly. It takes roughly 2 weeks for a feature on the far side to travel all the way back around to the Earth-facing side. Those 2 weeks felt long. As we covered earlier, some sunspots fade on the far side, others survive. The question was which version of AR4366 would come back. The indirect signals scientists were picking up during AR4366's 2-week absence gave them cautious hope, or cautious concern depending on how you look at it. The region appeared to still be present, still carrying structure, still large, but you don't know for certain until it comes back into view. Scientists monitoring the sun during this period were also watching something else, solar activity overall, because while AR4366 was hidden, the sun's Earth-facing side had been going through a dramatic shift. After weeks of almost constant activity, flares, eruptions, sunspot after sunspot rotating into view, the sun had begun to quiet down. And then, just as scientists expected AR4366 to reappear, that historic spotless day arrived. The timing could not have been more striking. A return to calmer conditions, the beginning of the sun's gradual wind down toward the next solar minimum. But that stillness ended quickly, because less than a day after that historic blank sun, while astronomers were still documenting it, still writing about what they had just witnessed, something began to appear on the far eastern edge of the sun, something that a lot of people had been quietly watching for. The first edge of AR4366 was rotating back into view. And when scientists saw the first images from NASA's Solar Dynamics Observatory, they knew immediately. This wasn't a faded remnant. This wasn't a quiet, harmless smudge. AR4366 had survived the farside transit, and it was still big. So when the first hint of AR4366 appeared on the edge of the sun on February 23rd, scientists watched closely. Because now the question wasn't whether it had survived. The question was, what condition was it in, and what would it do next? The data showed something that surprised scientists. When AR4366 began rotating back into Earth's view on February 23rd, the morning after the historic spotless day that broke nearly 4 years of unbroken solar activity, what scientists found was not the quiet, faded remnant of a region that had burned itself out. It was still there, still large, still structurally intact, the magnetic configuration that made AR4366 so dangerous during its first Earth-facing pass, that tight, coiled, high-tension beta-gamma-delta structure, appears to have survived the farside transit. Let me put that in plain terms. When AR4366 left our view in early February, it was still carrying high levels of stored magnetic energy. Scientists hoped it might have unloaded some of that tension during its 2 weeks out of sight. Instead, what came back around the corner still appears to be carrying most of that same dangerous magnetic energy. It isn't fully visible yet as of this recording. The sun's rotation brings it gradually into view over the course of days, and by around February 25th, the full active region will be rotating through what solar scientists call the central meridian. That's the position directly in the center of the sun's Earth-facing side. It's the point where any eruption has maximum potential to send solar material directly toward our planet. That window, late February through the end of the month, is what scientists are watching most closely. And here's something worth knowing, because it matters for what this region might do next. By the time this recording was made, AR4366 was already showing early signs of activity as it rotated into view. Low-level eruptions, not the massive events it was producing during its first pass, but activity. Signals. The region is not dormant. Now, and I want to be careful and honest with you here because this is important, solar activity cannot be predicted with certainty. No scientist in the world can tell you definitively that AR4366 will fire a major flare during this Earth-facing window. What they can tell you is that the conditions for major eruptions are still present. The magnetic structure that drove those 50-plus flares during the first pass is still intact. The region is still large, and it is now rotating through the most dangerous position on the Sun relative to Earth. That is a confirmed risk, not a guaranteed event. The difference matters, and any source that tells you a major eruption is definitely coming is going beyond what the science actually says. What the science says is, watch carefully, the conditions are serious. NOAA's Space Weather Prediction Center is issuing formal advisories and tracking this region around the clock. NASA's Solar Dynamics Observatory is capturing live imagery every few hours. Both the monitoring and the concern are real, and the timing, right now, this week, is the window everyone is watching. Here's what scientists are specifically watching for. As AR4366 rotates through the central meridian position, they're monitoring several key indicators. First, they're watching the magnetic field structure. Is it stable or is it shifting? Shifting magnetic fields are often the precursor to major eruptions. Second, they're monitoring the sunspot size and complexity. Is it growing? Is it maintaining its beta-gamma-delta classification? Third, they're tracking any low-level flares or minor eruptions. Those can be early warnings that the region is building towards something larger. And fourth, they're watching the solar wind environment around Earth. Because even if AR4366 doesn't fire a major eruption, the Sun is still active in other ways. There are always streams of solar wind flowing outward from the Sun. Some of those streams are fast, some are slow, and when Earth moves through a fast stream, we can experience minor geomagnetic disturbances even without a direct eruption aimed at us. Right now, Earth is already moving through one of those fast solar wind streams. That's why NOAA has already confirmed some aurora activity reaching lower latitudes this week, before AR4366 even reaches full view. So there's already a baseline level of geomagnetic activity happening. If AR4366 fires a significant eruption during this window, it would add to that existing activity and potentially create much stronger effects. That's the situation scientists are monitoring. Not a single event waiting to happen, but a complex dynamic environment where multiple factors are in play at once. And AR4366 is the most significant of those factors right now. So the question becomes, if it does fire, what does that actually mean for us here on Earth? What happens when a sunspot this powerful erupts while pointing directly at our planet? Let's get into that. So what does it actually mean in your daily life, right where you are? If AR4366 fires another major eruption this week, here's what actually happened during its first Earth-facing pass in early February. When AR4366 was firing those large eruptions, a few things happened that affected people in practical, everyday ways, and some of them were surprisingly quiet about it. Across the side of Earth that was facing the Sun when the largest flares hit, high-frequency radio communications went dark. Not everywhere, not forever, but for stretches of time that range from minutes to hours. That matters most to commercial aviation, to maritime shipping, to emergency services that rely on certain radio frequencies. Pilots on long routes noticed it. Some communications had to be rerouted or delayed. It wasn't catastrophic, but it was real. GPS systems, the navigation technology in your phone, in your car, in precision farming equipment, in delivery trucks, became slightly less accurate during the storm periods. Not broken, not useless, but shifted just enough to cause issues for systems that depend on extreme precision. Again, most people didn't notice, but people working in industries that rely on centimetre-level GPS accuracy, they noticed. Power grid operators in some northern regions quietly activated protective protocols, systems designed to buffer electrical infrastructure against the kind of magnetic surges that geomagnetic storms can produce. Most of the time, those protocols work exactly as intended and nobody notices, but they have to be activated, and during a particularly strong event the margin for error shrinks. Now, those were the practical, somewhat quiet effects. Here's the beautiful one. When AR4366 fired during that first pass, the geomagnetic disturbances it created brought northern lights to skies where millions of people hadn't seen them in years. Northern lights, auroras, appeared far farther south than they normally do. People in the northern United States, across Canada, across northern Europe, stepped outside at night and saw bands of green and red light moving across the sky. It was genuinely stunning, and it was real, and it was caused directly by the same sunspot that we're talking about right now. If AR4366 fires a significant eruption during this Earth-facing window, and if any resulting solar material travels in Earth's direction, that same light show could return. NOAA has already confirmed that some aurora activity is already reaching lower latitudes this week from the current solar wind stream arriving before AR4366 even reaches full view. So there's a real possibility that over the next several days, on a clear night, people across a wide stretch of North America and Europe could see something in the sky that most of them have never seen before. That's the other side of what this sunspot brings. Not just disruption, not just technical alerts and protective protocols. Sometimes the same solar activity that disrupts technology also creates some of the most striking natural displays visible from Earth. And we may be heading toward exactly one of those moments. Here's what's actually happening when you look at an aurora. When the sun fires a major eruption, especially one that's aimed at Earth, it launches a massive cloud of charged particles into space. That cloud travels outward from the sun at incredible speed, crossing the distance to Earth in anywhere from 1 to 3 days, depending on how fast it's moving. When that cloud reaches Earth, it collides with our planet's magnetic field. Earth's magnetic field acts like a shield, deflecting most of the incoming particles around us. But some of those particles get funneled down toward the poles, the north and south magnetic poles, where the field lines converge. Those particles then collide with gases in Earth's upper atmosphere, and when they collide, they release energy in the form of light. That light is what we see as the aurora. The colour depends on which gas the particles are hitting. And at what altitude? Green light, the most common aurora colour, comes from oxygen molecules being hit at lower altitudes. Red light comes from oxygen at higher altitudes. Blue and purple come from nitrogen. The result is shifting bands of coloured light that move across the sky. During a strong geomagnetic storm, the kind that AR4366 could produce if it fires a major Earth-directed eruption, those auroras can be seen much farther from the poles than usual. Instead of only being visible in places like Alaska or northern Canada or northern Scandinavia, they become visible across much wider areas. That's what happened during the first AR4366 pass, and that's what could happen again. So if you live anywhere in the northern United States, across Canada, across northern Europe, or even farther south if the storm is strong enough, keep an eye on the sky over the next several nights. Check the aurora forecast. If conditions are right, you might see something extraordinary. But the auroras are just one part of the story. The other part, or the part that gets less attention but matters just as much, is what happens to the technology we rely on every single day. And that's where the conversation gets more serious. What's happening this week isn't just about one sunspot, it's about something much bigger. The sun runs on an 11-year cycle. Every 11 years or so, it goes from a period of deep quiet, very few sunspots, very few storms, through a gradual ramp-up of activity, reaches a peak of intense solar activity, and then slowly winds back down to quiet again. We're in solar cycle 25. And here's where things get interesting. Solar scientists confirmed that solar cycle 25 reached its peak, its official solar maximum, in October of 2024. Since then, the cycle has been on a gradual path back toward quieter conditions, a process that takes several years and never follows a perfectly straight line. But, and this is important, the beginning of the descent is not a calm, peaceful slide. It's volatile, erratic, unpredictable in a specific way. Here's the best way I can explain it. Think of a storm that's just beginning to weaken. Right at the moment it starts to lose its overall power, it can still produce intense, concentrated bursts of activity, sometimes stronger individual gusts than it was producing when it was at full strength. The overall energy is going down, but the individual events can still be dramatic. That's exactly what solar scientists say happens in the early declining phase of a solar cycle. The sun's overall activity starts to drop. Spotless days begin returning, like the one we just saw for the first time in nearly 4 years. But mixed in with those quiet stretches, you still get active regions like AR4366, regions that carry enormous stored magnetic energy, regions that can fire massive eruptions even as the cycle winds down. And what we saw in the space of one day this week, a completely blank, spotless sun on one day, and the return of the most active sunspot of the entire cycle the next, is a perfect, almost textbook illustration of exactly this phase. Scientists watching solar activity right now are seeing the transition happen in real time. The spotless day was the cycle pulling back. AR4366's return is the stored energy of the peak still working its way out. These two things are happening at the same time, simultaneously, on the same star. And if you want to understand what the sun is doing right now, not just this week, but over the next several years, that contrast tells you almost everything you need to know. The sun is winding down. But it isn't done yet. Here's what this means for the years ahead. Solar cycle 25 is now officially in decline. That means that over the next several years we should expect to see fewer and fewer sunspots overall, more spotless days, longer quiet periods. The sun gradually returning to the calm, dormant state it was in back in 2019 and 2020 during the last solar minimum. But the transition isn't smooth, and the early years of the decline, the years we're entering right now, are often marked by occasional bursts of intense activity. Even as overall activity decreases, the sun can still produce powerful bursts. The stored magnetic energy from the cycle's peak doesn't disappear overnight. That's what regions like AR4366 represent. Pockets of stored magnetic energy that are still powerful enough to produce major eruptions, even as the overall cycle winds down. And because those regions are less common during the declining phase, when they do appear, they tend to stand out. They tend to be closely watched. They tend to produce the most memorable events of the entire cycle. So in a strange way, the fact that we're seeing a sunspot this powerful right now, right at the beginning of the decline, is not unusual. It's actually expected. It's part of the natural rhythm of how the sun behaves. But that doesn't make it any less significant. Because while the overall trend is toward quiet, the individual events can still be powerful. There's something else worth noting here. Solar scientists study these cycles not just to understand the sun, but to understand how solar activity affects Earth. And one of the things they've learned over decades of observation is that the impacts of solar storms are not evenly distributed. Some storms produce dramatic auroras, but very little technical disruption. Other storms produce significant technical disruptions, but relatively quiet auroras. The effects depend on the specific characteristics of the eruption, the speed and density of the solar material, the angle at which it hits Earth's magnetic field, and even the current state of Earth's magnetic field at the moment of impact. That's why monitoring is so important right now. That ongoing monitoring is what gives us the best chance of knowing what AR4366 will do before it does it. Because the period when Earth is most directly in line with any eruption is happening right now. And while we can't predict with certainty what will happen, we can watch carefully and be ready to respond if something does. So where does all of this leave us? What should you be paying attention to over the next several days? And what does it actually mean to live through a moment like this? So here's where things stand right now. AR4366, the sunspot that made February 2026 the most active solar month in years, is back. It survived 2 weeks on the far side of the sun. Its dangerous magnetic structure appears to be intact. It is now rotating through the most Earth-facing position possible, and the window we're watching most closely runs through the next several days. Will it fire a major eruption? Honestly, we don't know. Nobody does. That's not a failure of science. That's just the nature of the sun. Solar activity can shift rapidly. A region that looks quiet in the morning can produce a major flare by evening. A region that looks dangerous can gradually ease without ever firing another large eruption. What we know is that the conditions are serious. The region is there. It's active at a low level. It's in the right position. NOAA is watching it around the clock. If something significant happens, you'll know about it. Official alerts come from NOAA's Space Weather Prediction Center. That's the most reliable, real-time source for what the sun is doing and what it means for Earth. You can find them online if you want to follow along directly. And here on this channel we'll be covering every major development as it happens. But I want to close with something that I think is worth sitting with for a moment. We are living in an extraordinary period of solar history. The sun just gave us its most active month in years, and then went completely blank for the first time since 2022, and then brought back its most powerful sunspot, all in the space of a few weeks. That kind of drama is rare. Most people live their whole lives without a solar cycle that looks like this one, and you're watching it happen, in real time. You're not just a passive observer, you're paying attention, you're asking questions, you're trying to understand what this giant star at the center of our solar system is actually doing, and what it means for all of us here on Earth. That kind of curiosity matters more than most people realize, because understanding the sun, even at the basic level of knowing when to look up, when to check the aurora forecast, when to pay attention to space weather alerts, connects us to something much larger than our daily routines. We live inside a solar system. We live under a star that is active and powerful in ways that most of us were never taught to pay attention to. AR4366 is a reminder of that. For most of human history, people watched the sky because they had to. They tracked the movements of the sun and the moon and the stars because those movements determined when to plant, when to harvest, when to prepare for winter. The sky was part of daily life in a way that it isn't anymore for most of us. We've built lives where we don't have to look up very often. The lights are always on, the GPS always works, the radio always connects. But there are rare moments when the sun reminds us those things can be briefly disrupted. And in those rare moments when the sun reminds us that it's still there, still powerful, still capable of reaching across space and touching our lives, we get a glimpse of something our ancestors understood deeply. We are not separate from the universe. We are part of it. And the things that happen out there, on the sun, in the space between the sun and Earth, those things matter down here. AR4366 is one of those reminders, and whether it fires a major eruption this week or quietly fades back into the sun's surface without another dramatic event, the fact that we're watching it, the fact that we're paying attention, the fact that we're asking questions, that matters. So keep watching, keep asking questions, and if the sky lights up with auroras over the next few days, get outside, look up. Because what you'll be seeing isn't random. It'll be energy from this same sunspot lighting up our sky. If this video helped you understand what's happening with our sun right now, hit that like button. It genuinely helps more people find this kind of honest, clear coverage. And subscribe so you don't miss the next update. Thank you for watching, and I'll see you in the next one.